Okay, so I want to try to get through this kind of fairly fast again, just like I did some of the other ones, just because I want you to have time to do work on your stuff and to have time to write this stuff down. You can always remember pause, rewind, fast forward, all that cool stuff. Okay, this particular topic is really done with parallelograms. Now we're just proving that quadrilaterals, which ones are parallelograms. Okay, so for this first example, it's asking us, is this a parallelogram? Well, some of the things that we see, opposite sides are congruent, but in order for it to be a parallelogram, then we need both sides to be parallel. Well, if we split this up into two triangles, then you'll notice if we split it up to two different triangles, then we have this is what you'll have when you split them up. Well, you'll also know too that these two triangles also share a side AC here and here. Because they share that side, then these are also going to be congruent. Now we have two triangles that are congruent based off of side, side, side. Now that we know that the triangle is congruent, then we know that every part is congruent. Since we know that every part is congruent, then we know that these two angles are going to be congruent. These two angles are going to be congruent. Let's see. Sorry, messed up a little bit. This angle C is going to be the same as angle A on the other one. Remember, the reason why I say that is because this is in between the one with 3 tick marks and the one with 1 tick mark. Same over here. 3 tick marks and 1 tick mark. It's supposed to be 1 tick mark. So, those two angles are going to be equal or congruent. This one, angle A, is going to be congruent to angle C. And then angle D is going to be congruent to angle D. Okay, so since we have all those sides, well, because of this angle here and this angle here, C and A be congruent, that's also alternate interiors. Same as what we'd say about angle C and angle A, also alternate interiors. So if those are also alternate interiors, then they have to be parallel. Since they're parallel, then it has to be a parallelogram. Okay, so basically I just kind of wrote down, because of the alternate interiors angles converse theorem, I should probably put that in there as well, theorem, then this is going to be a parallelogram. And the converse of the alternate interior angles theorem is basically saying if you have two things that are alternate interior, then you're going to have two lines that are parallel. Now, I want you guys to try it on your own. Pause this, give it a shot, then come back. Hopefully you took more than 5 seconds to take a look at it and try to think of it on your own. The reason why you cannot conclude is, yes, we do have two separate triangles. And you'll notice that we have a similar situation where they share this side. Well, the issue becomes is, in order for it to be a parallelogram, then you need to have opposite sides to be congruent, okay? This and this are opposite sides. They are not congruent. Just like this side and this side are also not congruent. So the reason why you cannot conclude that this is a parallelogram, opposite sides are not congruent in this diagram. And magically appeared is the answer for this. Hopefully you guys, like I said, you guys pause and do these things like that. And if I do something too fast or I pause and come back and something happens, let me know where I can make some improvements on. Because I'm still trying this out. I've done this a few times, but I'm always looking to become a little bit better. All right, theorem alert here. This one basically is saying that this is a converse of one that we did before. Remember, converse meaning switching really the lettering of the words around. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. The ones that we dealt with before was if the quadrilateral, and we use the pencil part, if the quadrilateral is a parallelogram, then both pairs of opposite sides of the quadrilateral are congruent. This is just the opposite of what we just talked about yesterday. Okay, on this problem, Teo sketches the design of a quadrilateral-shaped building. If angle 1 is supplementary to 2 and 4, his design is a parallelogram. So angle 1 is supplementary, which of course remember means equals 180 to 2 and 4, which I realized I said it backwards. So is his design a parallelogram? Yes, it is, and that's based off what we talked about yesterday as well. If you have a parallelogram, then your consecutive angles are congruent, and our consecutive angles are congruent here. So yes, this is a parallelogram. So this next one, it's a little bit trickier on this. So it says, Teo sketches the second design. It says 1 and 3 are congruent, and it also says 2 and 4 are congruent. Okay, well, we have to go a little deeper with this one. Okay, so we have angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to 360. Okay, because that's how much a sum of a quadrilateral equals. Well, we know that 2 is the same as 4. So we can actually substitute this to make this angle 2. 3 is the same as 1. So we could substitute that one to be angle 1. So now we have angle 1 plus angle 2 plus angle 1 plus angle 2 is equal to 360. So then we can actually group these together, since there's 2 angle 1s, 2 angle 2s, so we can put a 2 in front and say angle 1 plus angle 2 is equal to 360. Divide both sides by 2, and we end up with angle 1 plus angle 2 is equal to 360. I mean, not 360, 180. So now we can actually, from up above, it says 2 is the same as 4. Let's replace that and say angle 1 plus angle 4 is equal to 180. Well, that's a consecutive that we talked about consecutive angles being supplementary. Yes, this consecutive angles are supplementary. Because they are supplementary, see both of them right here. 1 plus 2. And if you look in our diagram, we have 1 plus 2. And then we also have 1 plus 4 here equals 180, which is this consecutive right here. So yes, we have consecutive being supplementary, therefore this is a parallelogram. Now, don't you feel smart in knowing that? I know you do. Okay, so you guys try 5 and 6 and pause it, work it out, and then I'll work it out for you. Angle D will be opposite of angle F, so that is going to be 27. Not much math on that one. And then it says, is DEFG a parallelogram? Well, not only is it opposite to notice that that's 27, we could also do 360 minus everything else. 153 minus 153 minus 27. And when you subtract all that, you end up getting 27. So is this a parallelogram? Yes, it is. Why? We have opposite and you have consecutive angles are supplementary. do number 7, pause, or pause this, do number 7, and then come back. Just based off looking at this, we do have a set of, and it's in orange, the top two there, this one is supplementary. That does equal 180. But if you look at the green circled one, when you add those up, that is actually not 180. That is going to be 178. Not 168, 178. So that is not supplementary. So these aren't supplementary, therefore this is not a parallelogram. And the reason was because only one pair of consecutive angles are supplementary, not both pairs, not on both sides. Which leads us to the next converse of theorems. If an angle is a quadrilateral, it's supplementary to both consecutive angles, then it is parallelogram. Same thing as the one within the next one is if you have opposite angles of a quadrilateral that is congruent, then it is a parallelogram. Instead of opposite before, where we're saying if it is a parallelogram, it has opposite angles congruent. This is saying if you have opposite angles, then you have a parallelogram. So number 7, we have a parallelogram, one that tells us, and then wants us to find the value of R and S. Well, if it's a parallelogram, we know that opposite sides are the same, or congruent. So we know that these two are congruent, and we also know that the opposite sides of X, Y, and WZ are also congruent. So let's set those up. So now I got these set up, we can solve for S. So S is equal to 7. And then on the other side, when we look for R, subtract 4R from both sides. End up with 7 is equal to 3R plus 1, subtract 1. So we end up with 3R is equal to 6. So then divide both sides by 3, R equals 2. What can make this one a little bit trickier is, we'll be able to see it, is we look at things like this and go, well, this one has a B and an A. We can't say 5A plus, we cannot say 5A plus 4B plus 1 equals 180 because I'm not eliminating anything. But what you can do is, since it is a parallelogram, we know that opposite angles are equal. So we could set these two equal to each other, and then we could also set these opposites equal to each other. So let's set that. So I set them up equal to each other, and ended up solving for A, and I got A to be 7, and then when I set up the other two diagonals, basically angle R and angle T, I got B to be 36. So the values for A and B is A is 7, B is 36. So of course I want you guys to try the next. See 9 and 10. Yeah, try 9 and 10. Pause. Come back for the answer. Okay, so now we have worked these out. So I got angle P to equal 40, and I got angle R to equal 40. So they're opposite angles to check out. So that works so far. So now we have angle Q, and I wrote it backwards. So we have angle Q and angle P. Not angle P, angle S. So we got those that equal 140, so that checks out. So the next thing we have to check out is P and Q supplementary? Is R and S supplementary? So we take their answers, 140 plus 40 equals 180, and then we come down here, 140 plus 40 equals 180. So not only are the opposite angles congruent, but their consecutives are also supplementary. So yes, this works out, and this is a yes. So this is about to conclude the first video, and first video for this particular section. Remember, I only have 15 minutes because it's the free version, and I'm cheap. So I'm going to have to conclude this one, and then upload the next one and then finish off the rest of it in the next video.